Hey guys, so today we are going to start into a new topic. We're going to talk about topic 16, which is introducing probability. So today our focus is going to be on likelihood and just general probability. So to start things off, general probability, we can use particular words to describe how likely something is to happen. So how likely an event is to happen. Those words are listed here below, and we use impossible, unlikely, as likely as not, likely, or certain. So we're going to look at some different events, and we are going to decide which of those best describe how likely the event is to happen. So our first one here, you will go swimming on a hot day this summer. Now, for that event to occur, that is fairly likely. When we write probability, though, so we're going to write a P for probability, we write probability a very specific way. So we're going to write P for probability, and then we're going to write the event in parentheses. So the probability of swimming is likely. So I'm going to write likely. Okay. Now, our next one, the probability that there will be children wearing costumes on Halloween. So the probability of costumes, and that is certain. We know that on Halloween, there are going to be children wearing Halloween costumes. So that outcome would be certain. Okay. The probability that your hair will grow 5 inches in one day. So probability, and I'm just going to write hair, 5 inches. That is impossible. That is not going to happen. Let me go ahead and just scroll that up and we'll fix that. So impossible. All right, so then the probability that you flip a coin and it lands on heads. So looking at our choices above, the probability of getting a heads is as likely as not. That means we have an equally likely chance of getting heads as we do tails. So this is as likely as not. Okay, and our last one here, the probability a student in your class will become famous next year. So probability of famous. This is not impossible, but it is unlikely. So we're not saying it can't happen, but it's not very likely to happen, so that is an unlikely event. Okay, so looking here at measuring probability, we have some specific ways to measure probability. Probability is measured as a number between 0 and 1. The closer the value is to 0, the less likely it is to happen, and the closer the value is to 1, the more likely it is to happen. When we write probability, we can use 3 different formats. We can use fraction, decimal, and percent to express how likely or unlikely something is to happen. So we are going to use those rules for switching between fractions, decimals, and percents. You have learned already how to change fractions to decimals, decimals to percents. So we're going to use those rules and kind of changing back and forth between them. All right, so if we look at this next chart, we have 3 different outcomes that have a specific fraction, decimal, and percent assigned to it. So if we look down here at impossible, if something is impossible, that means there is no chance that it could happen. That means it has a probability of 0 or 0%. So our fraction is 0, our decimal is 0, our percent is 0. There is no other fraction, decimal, or percent that we could write for an impossible outcome. Now, on the other end of that, we have certain. If something is certain to happen, that means it is definitely going to occur. That means the fraction would simplify to 1, so maybe it would be 5 out of 5 or 10 over 10, but it would simplify to 1. The decimal would be 1 or 1.0, and our percent would be 100%. Again, there are no other numbers that we could write for something that has a certain outcome. Now, the other one is if it is as likely as not to happen or to occur. If it's as likely as not, then that is going to have a fraction of 1/2, a decimal of 0.50, and a percent of 50%. So if you remember from the example before, we talked about the probability of flipping heads on a coin. That would be 50%. That would be 1/2 because it has an equally likely chance of landing on heads as it does of tails. So that would be 1/2. Now, if something is unlikely to occur, it's going to be between 0 and 1/2, or 0% and 50%. That would be an unlikely outcome. It doesn't have to be 1/4, 0.25, or 25%, but it would be a fraction, decimal, or percent between our impossible and our as likely as not, which is also the same for likely. So it doesn't have to be 3/4 or 0.75 or 75%, but it is going to be a fraction, decimal, or percent that is between our as likely as not and our certain. So maybe it might be 2/3, or it might be 0.6. That would be a likely outcome, but it would be between as likely as not and certain. So we're going to take a look at some practice. It says use the probability given to classify each situation as impossible, unlikely, as likely as not, likely, or certain, and we're going to rate each probability 3 ways. So we're going to be given the probability one way, and we're going to rate it the other 2. So we have probability equals 0.65. So that's a decimal. If I write it as a percent, all I have to do is move it 2 decimal places to the right, or multiply by 100, which would give us 65%. And if I write that as a fraction, it's 65 hundredths over here, so we would write 65 over 100, or we could even simplify that further to be 13/20. Now, since it's 65%, or 65 over 100, that is between 50% and 100%, so that is likely to happen or likely to occur. Our next probability is 50%. As a decimal, that would be 0.50, because I would just move my decimal point over to the left 2 places. Or I can write this as a fraction, as 50 over 100, which simplifies to 1/2. Again, since our fraction is 1/2, our decimal is 0.50, our percent is 50%, that tells us that this event is as likely as not to occur. So our probability is as likely as not. Okay, and then our last one, we have the probability is 1/5. So if we want to change that, we want to change our fraction to a decimal and to a percent. If I divide, I would get my decimal of 0.20, and then to write that as a percent, I just move my decimal point 2 places, and I would get 20%. Now, with a probability of 20%, or 1/5, that is going to give us an unlikely outcome, because it is less than 50%, but more than 0. Okay. Now we are going to look at how we use probability and what we can do when we're using probability. So probability can be given to you in an equation form. So for example, the probability of flipping tails on a coin can be written as 1/2, 0.5, or 50%. So the equation looks like this right here. Probability P of tails equals 0.5. So we would read this like the probability of tails is 0.5. To use the probability, we can use our percent proportion. So we have been using proportions in a lot of different ways in math, but ultimately each time we were writing this as part over whole, right? Our part was on top and our whole was on the bottom. And we also referred to our part sometimes as is and our whole as of. We use that in different parts of our problems. Now, we always put our part over whole was equal to our percent over 100. And the percent was always put over 100. Percent is equal to, or the percent equals probability of an event happening. You might need to change it from a decimal or fraction to a percent when we write it using a proportion. Again, our is our part, our of is our total amount, or our whole. So let's take a look at some practice, and we're going to set up proportions to solve. So we're going to answer the following questions, again, using our percent proportions. There is a bag with a total of 50 Jolly Ranchers, right? 50. The probability of picking a blue Jolly Rancher is represented with the equation probability of blue equals 0.18. How many blue Jolly Ranchers are in the bag? Well, we are given a decimal here, and we want to write this as a percent. So 0.18, we move our decimal point 2 places to the right, and this is 18%. Knowing that we have our percent here, I'm going to set up my proportion. Up here it says there's a bag with a total of 50. It's telling us total, so our 50 is our whole. So I'm going to set up my proportion. I have 18 over 100 because 18 is my percent. And then I have my whole is 50, so I'm going to have x over 50 because what I'm looking for is the part that is blue. Once I have my proportion, I just come over here, cross multiply. I'm going to do 18 times 50 equals 100x, or 100 times x. 18 times 50 is 900. So 900 equals 100x, and then I can divide both sides by 100. And I'm left with 9 equals x, which tells us that there are 9 blue Jolly Ranchers. Okay. We're going to take a look at number 2. There's a box with different colored pencils in it. The probability of picking a green colored pencil is 40%. So we are given our percent right here. If there are 150 colored pencils in the box, how many of them are green? So our 150 right here, that is our total, that is our whole. And they already tell us that we have 40% that are green. So we're going to set up our proportion. I'm going to put 40 over 100. And I'm going to have on this side of my proportion x over 150 because again, my whole is 150 and x is representing the part of them that are green. So I'm going to cross multiply. So I have 40 times 150 equals 100x. Again, I'm going to multiply 40 times 150, and that's going to give me 6,000 equals 100x, and I am going to divide both sides by 100. What that tells me is that x is equal to 60, which means we have 60 green pencils. Okay. Now for our last problem, we have actually 2 parts here, and I'm going to close out my video just so I have plenty of space to write and show you what we're doing. So the question says, based on last year's record, a fan expects the probability the blue team will win is 0.35, and that the yellow team will win is 2/5. If there are 180 games in the season, what team will win more and how much more? So I'm going to start with my blue team. And I am told that they expect the probability to be 0.35. Now, I need to convert this decimal to a percent, And 0.35, if I move my decimal point 2 places, is 35%. So for blue, we expect them to win 35%. And it says if there are 180 games this season, this is going to be my whole, my 180. So when I set up my proportion, we have x over 180 equals 35 over 100. From here, I just do my cross multiply, and I have 180 times 35 equals 100x. 180 times 35 is 6,300. So 6,300 equals 100x, and I'm going to divide both sides by 100. And that's going to tell me that the blue team is expected to win 63 games. 63 equals x. Now I'm going to draw a line here, and now I'm going to show yellow. The yellow team was expected to win 2/5 of their games. And if I change 2/5, the fraction 2/5 to a decimal, I'm going to get 0.4, which is 40%. So I'm going to use 40% for the yellow team. And again, we're looking out of 180 games. So my part is x because that's what I'm looking for. Over my whole is 180 equals 40% over 100. So again, I'm going to cross multiply. This time I'm going to do 40 times 180 equals 100x. All right, so 40 times 180 gives me 7,200 equals 100x, and I'm going to divide both sides by 100, leaving me with x equals 72, meaning the yellow team is predicted to win 72 games. So if I look at that and I compare those, our question said what team will win more? Well, the yellow team is going to win more because they're going to win 72 games, and the blue is going to win 63. And then I would just subtract those to figure out how many more. So what I would find is yellow team wins 9 more games. All right, so hopefully this helps you understand probability. If you have any questions, don't hesitate to ask your teacher. We're going to go on and do some practice, but if there was anything that you were confused about, feel free to go back and rewatch parts of the video. Again, as always, you can pause it, go back, do what you need to do. Ask your teacher if you have any questions.